times I will not publish the chat. It sends it to my email and then I just delete it because I don't see the purpose of publishing a chat. Like, it's just, anyway, it's pointless to me. Cool. So welcome to our meetup tonight. I'm so happy everybody could be here and that I'm sure more people will be joining us because we have an awesome topic today. If any of your companies are hiring or you are looking for a job, please join us on the Forge Slack group. I'll post the link in the chat probably 3 times tonight. But we ask you to put your posts there just because a lot of people do catch the recording of this because they've spent all day on Zoom meetings and don't always want to just sit through another meeting. So yeah, put all of your jobs on the job board on the Forge Slack. It's super active all the time. And that's really the best place to get traction. You can also, if you're looking for a job, there's also a secondary channel just to like post your resume if you want. But this one's got tons and tons of open jobs right now. Because I know Weave is hiring and I've only posted 9 job positions on there. So there's that. My next slide, I'm still looking for speakers. If you want to speak, please submit it on paper call. We accept everybody and anybody. It doesn't matter how many times you've spoken. I just hope that it has to do about Go. I don't accept Java talks, unfortunately, for this meetup. And yeah, if you're ready, Andy, I will turn the time over to you. Stop staring at my slides and let you go ahead and take over the show.
All right, thank you very much. All right, let me make sure that this is the right window. Everything's good. Got my code, got my demo, got my slides. Let's do this thing. Present now. A window. All right. Okay. Let me enable my presenter display, which is, there we go. All right. So tonight I'm going to be talking about embedding static web content with Go Embed and Go Generate. About me, I'm a longtime Go user since R60, I guess, or so. So that's pre 1.0. So that's about 2011 or so. I'm a Google developer expert in Go, and I work in security research and support, formerly with SourceFire and Cisco, now with CrowdStrike. I'm a huge nerd, and I have way too many hobbies. So Embed, what is it? It is a new package as of Go 1.16 and associated with a new directive, compiler directive, Go Embed. It is for embedding static assets into your compiled Go packages or executables. And it is done at build time and is completely transparent. So when you build your Go program, if you have embed directives and are embedding static assets, it will just happen. This allows you to embed package global variables, and that's an important distinction. Earlier in the spec, there was support for local variables, but there was a little bit of weirdness around that, and that support was removed. It supports embedding of 3 types of. It supports embedding assets into 3 types of variables: a byte slice, a string, and a file system, an embed FS, which is part of which implements the new file system interfaces in Go 1.16. I don't talk about those too much in this talk, but we can go over that at the end because there are some future work that I think is very interesting that involves them. So why would you want to use Embed? Well, it's one of the things that it's great for is to allow you to easily include resources that relate to your code or application, but aren't actually compiled code themselves. So this lets you version this data and embed it once, or rather write your embed directive once, while also tracking it with the rest of the code that it relates to in your version control system. It can also, this is useful for, say, images, front end code, really any kind of like pre-computed resource. So how do you use Embed? Well, let's take an example of the following file system. At the root of this repository, we have a Go mod and a main Go, along with a couple of text files we're going to embed into a byte slice and a string, respectively. And we also have an embed subdirectory containing further structure and more text files at a couple of different levels. And here we can see their contents. How do you use it? Well, first you have to import the embed package. This is the first requirement. And it is checked by the compiler. This works in conjunction with the Go Embed directive, which directs the compiler to embed an asset and specifies the relative path of the asset to embed. If the embed package is not imported, using this directive will result in an error. For the first example, we want to embed into a byte slice. The Go Embed directive tells the compiler that we want the byte slice B to be initialized with the contents of bytes.txt. A similar approach is used for a string variable. This will import the contents of string.txt into variable s. Both of these forms support only a path to a single asset. To embed more than one file, we can use an embed.fs variable, which represents the file system. This directive embeds the embed directory in our file system along with all of its contents into the variable f. However, because we're using a type from the embed package, this form requires the full import of the package. So no underscore import for this. So how does this work? During build, the Go compiler tool chain examines the source code of our program, generating a file in the work directory called embed config behind the scenes. When it finds an embed directive, it updates the contents of this file, generating a list of mappings and the full paths to the files they point to, until it finally has the complete list. Once the list is prepared, it can then begin to embed the assets directly into the binary. Here's a bit of how that's done. On the left, the embed package describes the structure of the embed.fs type, and on the right is the internal compiler code that actually embeds all three varieties of embedding into the binary as it's built. A couple of things are worth noting. For one, the embed package calls out that the compiler knows the layout of the fs struct. This is worth noting since it's the compiler that takes care of all of this for us. In the compiler itself, we see that it's actually inserting the symbols for the data directly into the binary as it's being built. In the case of a string or a byte, it's stored internally as a string symbol. But in addition, in the case of a byte slice, the cap is added to complete the slice header. Whereas for embed.fs, it creates the structure mentioned in the embed package directly. So that's it behind the scenes with how embed works. Let's talk about how we might use it. So recently I had an idea. I wanted to provide a Go module that anyone could use to embed an interactive version of an open API spec using a project called Swagger UI. For those who are unfamiliar, OpenAPI, formerly and somewhat interchangeably known as Swagger, is a specification language which defines a web API. It's written in either YAML or JSON, and it defines all of the routes of an API, as well as the types and documentation. It's very handy because in addition to documenting an API, it can be used to generate software which interacts with that API, both clients and servers. As for Swagger UI, it's a handy tool. It serves up the OpenAPI specification and is distributed as a self-contained bundle of web assets and front-end code, allowing you not only to view the specification, but optionally to interact with it directly using handy examples and pre-filled submissions, all from your browser. So this is an ideal use case for Embed since it's so self-contained. Combined together, this means that my module could allow users to provide their own OpenAPI spec as bytes and get a handler that served the UI with their spec embedded. They could even use Embed themselves to embed their spec into the API that they're building if it's checked in with it, which is embedception, right? And that seems like a pretty great solution, only there were a couple of small problems. For one, the bundle comes hard-coded to point to the example spec that we saw kind of being browsed in the video earlier. It's called Pet Shop. That's like the standard open API demo. So that's kind of a womp-womp situation. And the spec can also come in two different formats. So how do we handle that if we want to package it? Well, Go Generate to the rescue. So let me introduce you to our new, I guess, friend, Go Generate. With Go Generate, these problems have solutions, right? So, well, the bundle comes with the example spec. Well, I'll just tweak it, right? It can be either JSON or YAML. Well, it turns out that doesn't matter. And Go Generate can kind of help us with that too. And Swagger UI, well, it updates regularly, but I can just download it, right? So Go Generate is not actually our new friend, but rather our old friend. It's a tool to do some package buildy stuff to help modules that need stuff generated as part of their repository. So hence the name. It is unlike Embed, it has to be run explicitly. It's not done automatically because that's not exactly its purpose. It's very simple. It is another compiler directive, and it's just Go Generate and then your commands, and you run it with the Go tool and the generate kind of subcommand. So Go Generate, and then there you go. Basically, it just runs commands. Why would you want to use that? Well, it's really great for package maintenance if your code requires code generation, like say from a open API spec, or if there's some other non-code stuff that you want to version with your repository. It also means that you don't need special scripts to do things, since you can just write more Go code. And it's even better, right, if you can use it, with only the standard library, but there are tricks to that. So as for how to use it, well, since it just runs commands, you can kind of do whatever you want with it. But there are some best practices that are in keeping with its intent as a package maintainer tool, and it makes things sane. One of these is to separate it into a main package. Another one is, and we'll go over these, you'll see these in action in a little bit. Another is to exclude it from the build, and yet another is to use Go gettable dependencies, and ideally standard library, like I mentioned earlier. Combined with Embed, Go Generate can do some interesting packaging stuff. So how did I make use of these together? Using Go Generate, I was able to write regular old Go code to download the latest Swagger UI into my module after checking for updates, and then tweak those files or edit them a little bit to point to a standard spec location relative to the Swagger files so that the browser can access it. And we'll talk about these kind of one by one. But first, I'll go over the repository structure. So you can see at the top level, it's relatively simple. There's the main Go file for the package, swaggerui.go, a README, a license, and a Go mod, along with a get-ignore. And the embed directory, of course, are the contents of the Swagger UI bundle with some tweaks, but more on that shortly. Only a couple things stand out here. There's a current underscore version.txt and a generate.go. So what's up with those? Well, to explain, let's look at the code. Let's start with swaggerui.go first, the main and only file of the package. And yes, that's all of it. We'll get into the rest of that stuff in a minute, but note the Go Generate line. It simply calls Go run on generate.go. This is where generate.go is where all the heavy lifting is done. And in this way, it acts like a build script, only it has all the power of Go and any libraries we choose to apply to it. Also worth noting, VS Code and most IDEs probably actually, including Goland, I'm sure, provide a handy helper so that we can just run it directly from the IDE. So looking at generate.go, and here's the beginning of it. It's a fairly standard program with, admittedly, more than a few imports, but a couple of interesting differences worth calling out. For one, unlike the module it's a part of, it's in package main, meaning it builds a runnable binary. This is so it can be executed with go run in the generate directive in swaggerui.go we mentioned earlier. In most instances, like mixed packages are a problem, which is why we have that linter warning. But in this case, it's not a problem because of the other difference. Generate.go is also marked with a build tag ignore. So this means that it will not be built with the rest of the module. Combined together, these let generate.go serve its function as basically a script file, a support script file. The first thing generate.go does is talk to GitHub to get the latest release of Swagger UI, which is all fairly boilerplatey. But worth pointing out is that this is where current version.txt comes into play. This file is embarrassingly simple and is just a convenience to track the version we are using and whether or not it's still current. And honestly, it's not necessary. With a little more work, this can be done by checking the current repository tag, because my plan is, once I have a couple more changes in, to basically just version this and mirror the Swagger UI version. So in theory, they could just check that by calling git. But also, since go generate is not really something you're running all the time, it could just be skipped. Checking the version txt could be just skipped altogether in favor of just downloading it every time, printing the current version number that it found, and just leaving it kind of to the maintainer to track. It's a maintainer tool pretty much after all. The rest of the downloading and unpacking of Swagger UIs, it's fairly boilerplatey, and we can go over it afterwards if you like. But the next important bit comes after we have all the Swagger UI files. We open the index.html file that it was bundled with, and we swap out that hard-coded spec URL with a relative one. And note the lack of suffix. So it turns out Swagger UI is actually smart enough to figure out whether the spec is in YAML or JSON. So our bacon was saved there. If this was a problem, like I initially thought it was, and in earlier iterations of and you can actually view my embarrassing GitHub history to see it. But I actually thought that it would be a problem, so I initially coded it, where the user had to provide like an enum about whether their spec was in JSON or YAML, and it was totally unnecessary, so I removed it. So our bacon, the bacon was saved this time. But the quick win of not needing to use templating is pretty great. The original version of this also used templating, by the way, to swap those file suffixes. Yeah, that's all it did. Anyway, after this, it's just a matter of writing the file, our new kind of tweaked index.html file back out. And since this is a maintenance tool, after all, print out a helpful message to ourselves to remember to update. Returning to swaggerui.go, the rest of it's actually pretty simple. We want the user to provide us a spec, but we want it to be accessible in addition to the rest of the handler. So to do this, this is where HTTP serve mux comes into play. And you can see that, let's see, is there a way for me to do markup in this thing? No, it doesn't matter. You can see that there is, I'll go over this when I talk about the file system stuff. But the handler creates wraps the embedded file system, which is all the Swagger UI files that we downloaded, and then it adds a Swagger spec mux route just over top of that, so that when the browser hits, the browser is asking for the spec, then we feed it back the bytes that the user provided us. Otherwise, we just feed them anything else from the Swagger UI, like embedded code. For future work, there's a lot of interesting potential here. All right, so Go generate can do whatever, right? And in prior versions, I was using it to embed a useless template directive. But what you could do is you could add in levels of customization. So, for example, if we go back to the Swagger UI kind of example, You can see there's above the URL, right? There's a layout, there's plugins that it comes bundled with and stuff like that. We could conceivably replace, kind of search in and replace those directives and allow the user to provide their own templates or their own like bundled specs if they want to use them or turn things on and off. Man, I should not have used all these animations. That's fine. This is fine. Everything's fine. But yeah, so there's a lot of potential for allowing kind of customization and kind of stuff like that. Oh my god, too many animations. I have a whole browser. Okay, back we go. All right, so what we could do in the future for projects like this, if you're embedding like web frameworks or stuff or front ends and stuff like that, that you want somebody to be able to customize. So for example, I could foresee building like kind of an Electron-like or really just any kind of using any front end framework, a web served API UI for your application, and then bundle that into a library, but allow the user to provide like an overlay file system for things like their own CSS files, their own graphics, any kind of customizations that you want to give them on top of any of the static code that you're serving, right? And check for what's allowed. And that is what I will be talking about, hopefully next time. And that's what I'm working on. So wrapping it up, Embed is still cool, right? Embed is cool and Go Generate is still cool. You can check it out. I'll send the link out. And if you guys want, we can kind of go over the code. I was going to like show you a little demo real quick. But before that, thank you. You're the best. Thanks for watching my presentation. So if you guys would like, I can take a look here at the I can show you the kind of Go Generate in action. Let's see here. Present now. There we go. Window. Here we go. So here is the repository that we were talking about earlier. And let's see if there's a new version of Swagger UI, right? So there's a new one. And we have now updated the vendor code in the repository, or the embedded code in the repository. So if we do a get, oops. Oh, no, that's fine. We can see that basically, or let's just do get status. You can see that so current version.txt has been modified, and a bunch of the files in this Swagger UI like embed directory have been modified as well. So when this package is built, it will be built with the current version of that code. For a quick test here, simple little file here. We load in a spec from swagger.json in this directory. This could also be embedded as a byte slice, and then call into the library to get the handle with that spec and handle it at root. So this is the spec itself. It's actually not very pretty.
That's beautiful.
Right. Oh, wait, that's right. Right. So here's our, kind of JSON spec. And then if we run it, maybe I'm being asked for okay. Actually, it should be fine. So that is at port 9000. Do a new window here. Yes. Oh, that's right. That's right. This is I was doing a replace directive. All right, so hold on. There we go. Now I'm being prompted for my, okay, so let's share the browser screen now. And then theory, it should be here. There it is, right? So 99% of all of this content is being served from the embedded assets. And then the spec itself, which you can see now is just called Swagger underscore spec. And then here it is, right? So that's being served with that serve mux and just kind of an overlay on top of the Swagger UI. We can talk real quick about IOFS.
Does anyone have any questions that they want to ask? Usually Carson's interrupted by now with a question, so I just want to give everybody a chance for questions if they have them. I mean, if not, go ahead. Matt, do you have a question?
You're muted.
Now you're frozen.
Hey, Jeff, frozen.
I'm actually super excited about this. I'm so tired of Packer and Packer 2. And
yeah, there's a lot of potential. I think the thing that I like the most about it really is just that it's got full kind of integration into the build tool system. And like, you know, when you combine like the ability to kind of package up and serve things as modules, I think is also very interesting. I think most people, most of the people I saw kind of chatting about this when it first came out were talking about how, how handy it would be, it's for, for version numbers, like embedding their own UIs and stuff like that. But, it works with modules too, right? So, you could kind of provide customizable, front end stuff or assets or really any kind of handler, right? And then just with a little layer on top of it, allow the user to customize those parts of it which they might want to customize, and then they don't have to mess around with embedding a framework themselves or any of that stuff. And you can take all the work out of that for them by just bundling it up. And like, if you can, like I did with Go Generate, providing the necessary kind of tweaks and like template directives and stuff if you can, or if you need to, right? And then basically you can provide your users with like a well-defined type that allows them to customize various aspects of that that front end or whatever that file system is that you're serving up. So for example, in the previous example, one of the things that you could do if we look at right, let's see, Swagger UI, and share this guy again. So if we look at Swagger UI, right, we go into the source. And so what you could do is basically go generate, and this is one of the things that I'm going to be doing with this library next, actually. You could insert a kind of dummy CSS file above this, so it takes precedence, but just have nothing in it, right? And then that'll be embedded in your file system. And so Go Generate would like insert that dummy into this file, and then it would also take care of creating the kind of the empty version of it in the embedded file system, so that if when the web browser goes to hit it, it won't be an error. But then you can allow the user to provide optionally the contents of that file to overlay it, and then change any aspect they want about how the front end appears to the browser without needing to modify any of the files in the embedded file system, which of course actually you can't, right? So you can bundle up these kind of front end frameworks with customization with this technique.
So I had a question about the IOFS type.
Yeah.
I'm looking at the docs and it has the one method which opens a file. If I'm reading the right place. My question is, have you seen any APIs that have been added in other packages specifically to exploit this new abstraction? For example, like text template or places like that, or have other APIs been retrofit to take advantage of what GoEmbed provides?
Yes. As a matter of fact, they have. And actually, by and large, if you're referring to the standard library, right? By and large, that has been entirely transparent. Any of the libraries that could benefit from using it have been kind of already ported over to it. One of the exceptions to that, and it was actually in my code, but I didn't call it out. And so if you don't mind yet another share, I will be more than happy to do it. So let's see here, window. Right. So in the swaggerui.go, right? A couple of different things that we do with, we'll come back to FS sub in a second, but the main root route that serves the file system, you'll note that there's this new kind of special method, HTTP FS, right? And the reason this is because the HTTP library for file servers already had its own abstraction of file system, http.filesystem, right? So in order to allow like embedded file systems, or really any other kind of file system to be served using that API, there's this like new helper method that lives in HTTP that will convert an IOFS into an HTTP.file system, right? So that's one of the kind of like, if I'm not mistaken, like pretty much the only place that like it's the kind of cracks show through with that like conversion, but everything else has been pretty transparent. Yeah, and so as far as FS sub, all that does is that, let's see if I can just pull up the little help tooltip, right? It returns a file system that's like kind of rooted that. So it's like it's sort of like a chroot for a file system, and it just kind of scoots it up a directory. So if you've ever used, if you've ever had to like do like the HTTP like trim path or whatever, it's kind of similar to that. You rather than having to tell the user to, because we want to be able to provide them a route that they can put wherever, right? And then the user just goes to that directory path, and then they get the UI. They don't want to go to that directory path /embed, right? So what that does is that kind of like chops that off at the beginning.
Okay, so I'm looking at line. Oh wait, could you share your screen
hold
again?
On. Yeah.
It was at line 12 on the GoEmbed.
Yeah.
So does that mean that the file or directory list after that directive, it's still, that FS is still rooted at the root of your project, wherever you're building?
Yes, it is relative to the embed location, right? Okay. So in this case, we, rather than, so when this directive, when you're using with a file system, it supports, more than one. You can embed multiple files into that file system, right? On the same line. And then they would come in without the prefix if they were at the same level. Mm-hmm. But then that would kind of require polluting like our entire tree with like the contents of like Swagger UI. Mm-hmm. So in that case, I chose to put them in this directory and then just chop it off, right? So yeah, it's relative to the embed directive here. And then it's basically just a file system that's rooted at /embed. And so that's why I kind of trim it off here, because I'm going to basically just be serving it, you know, from root as relative to wherever the user puts the handler.
Okay.
Yeah. Let's see. Anything else? All right, we can talk about IOFS. I mean, there's really not a lot to it. Let's see here. It's so in one of the interesting things about the share again. I mean, you know, you're getting like 30 shares for the price of one here, so like, I feel like, all right, no, not a tab. So confusing. All right, well, I probably should do a tab, but this has worked. So you have to see yourselves for a second. There we go. So yeah, it's a very simple like interface at its core, right? It just provides like open. So like, where does sub come from? Well, that's in like one of those kind of weird, kind of quirky standard library style of doing things. Rather, they assert on the method. So if we actually go to it, let's see here, fs, where is it? Yeah, so it asserts on whether or not it is a sub fs, right? Otherwise it like wraps it more or less. But they're the core interface for IOFS is actually very simple. But then like a lot of things are implemented with interfaces because different file systems satisfy different interfaces. And that brings up kind of an interesting, I guess, like caveat to overlaying these file systems. So one of the things that I ran into, actually, like, let's see here. This is the actual like Go issue for adding the file system interfaces, and then like I came in like way late, and I was like, hey, I wanted to follow up on that whole mounting thing, right? Because somebody early on in the proposal was wanted to be able to like kind of I guess like the opposite of sub, but like sub plus union or whatever, to mount one, like kind of basically combine two file systems in such a way that like you give it like a path in the first file system, and then if that path, you know, doesn't, I guess technically, you know, it's up to implementation whether or not you check whether it exists or not. But then that accessing that path would, and anything below it would give you like this second file system, which sounds like relatively easy. And it sort of is, but it's like you can get kind of most of the way there, but other things will be broken, such as like directory traversal, right? Which is like another kind of type that, or interface rather, that a directory has to implement. And then like, so if you're trying to iterate through something and you want to see your mounted directory, that's when it becomes difficult, right? So you definitely can kind of merge these file systems together for certain purposes. So for like for the web server kind of example I was talking about earlier, where you would let somebody overlay their own CSS, that would absolutely work. But like if you tried to make it generic in such a way that, because HTTP, the HTTP file handler will also take care of providing directory listings and stuff optionally, and it will attempt to kind of traverse the path to do that kind of thing. And that's where this will break down, because while you can wrap the open method to like look and see the prefix and then go to the sub file system or whatever, other things like traversing and like listing will break. And so for the uses like that I've been talking about with like web content, for the most part, that's fine. You can take a file system and then you can iterate it, right? If the user gives you an embedded file system, you can iterate it and make sure that, like, if you want that they're not giving you a file system with any files that are not allowed, right? Or that, you know, don't have anything to do with like the web content you're serving. You can do that, and then you can just kind of shove it in there, and like then basically whenever you get open, you'll check the overlay first and the second one. But like you wouldn't be able to like generically provide that in such a way that somebody could like navigate the directory tree from the browser, because like the sub file system just won't be there. Any other questions? Anything? Cool. Yeah. If anybody's interested, like I can, you know, go through the Go generate code at some point or whatever. But yeah, that's it.
That's awesome. We'll give you a thanks again. Oh my goodness, this dog. He's all tangled in my headphone cable and was literally scratching me the entire time. That was awesome. I was really excited for this because I have like 12,000 uses for my personal site now. So thanks for explaining all of them. Probably not everything, but all I wanted to know. And for agreeing to speak. And thanks everyone for coming. I'll stop the recording. Feel free to hang out and chat as long as you want. You're not obligated to stay.